Time series analysis of heart rate for stress prognosis in mobile video game genres, a study conducted by Nandan Natesan, Partvi Singh, and Nisha Atteri. The contents of this video include a general introduction and overview of the study, the data collection process, the pre-processing of the model, and the final model. We aim to collect and perform analysis on heart rate data, thus investigating the variations in heart rate during mobile video game play and unravel subtle physiological responses during gameplay. These findings could lead to game-specific stress management techniques, thus enhancing player well-being and shaping health-conscious game designs. The specifications of our system are as follows. We've used an Arduino UNO board as a microcontroller, a MAX 30102 pulse sensor for heartbeat detection, Arduino IDE for programming, processing for visualization of data, and a USB or battery pack for power supply. For data storage, a local storage or cloud-based storage was used. The multiple activities conducted throughout our study have been visualized diagrammatically in this flowchart. Our video game player plays two games, namely Clash Royale and Geometry Dash. The data is then passed to our MAX 30102 sensor via our Arduino UNO board. The heart rate data is then pre-processed and sent to our patch-TSD model and linear regression model, after which the time series stress analysis is conducted. Here we can see a circuit attached to our Arduino UNO board, and this is a snippet of the Arduino code used. The general setup of the project. Now let us move on to the data collection aspect.
In this video, we're going to talk about our data recording process. It is enabled by the MAX 30102 sensor, which is connected to an Arduino Uno board, which is connected to my laptop via USB. So what we're going to do here is we're going to record my average BPM values, which is enabled by an Arduino script. And we are going to use a software called Putty, which will store the BPM values in an Excel CSV file, which will be used as input for our models for further processing. So here what I'm going to do is I'm going to place my finger on the sensor and I'm going to go to the Putty software and I'm going to press open. What it does is it's going to start the program, and it takes a few time so it's initializing. So now it's recording my BPM values as I place it here. After a few seconds to calibration, it records my BPM values. So for our data collection, we recorded it for a 2-minute mark for each of the two games that we played. And once it records, we press cross, and once we close the session, under trial 3, it'll be recorded as all my BPM values. Thank you.
Once the data has been collected, we must now pre-process it before sending it to our models. Let's see how the pre-processing of the data occurs.
In this video, I'll be talking about our pre-processing of the data. This is after we've collected our data from the sensor. So as you can see here, the data.csv file contains the BPM values of both the games that we've collected data for, that is Geometry Dash and Clash Royale. So what we do is we run it through a Python script called preprocess.py, where we filter out the outliers in the BPM values. So we've set the minimum mark between 55 and the maximum mark between 220. So this helps in like taking out the outliers in our data set. Once we run this code, we get a data called filtered data. So this has the clean data, which we can then put into our next phase of preprocessing, which is augment.py. This script, what it does is, so since we need a large data set for training a model, we recorded roughly around 15 people's BPM values, and this augment.py is going to augment our data set into basically creating more values so that we can train our model on. So what we do is we use 3 methods basically in this augmenting.py program. The first is time warping, which will randomly shuffle the time indices of each series. And then we also add additive noise to add random noise to each time series according to our scale. And then we also use a method called time shifting, which shifts each time series by a random amount. So what this does is this gives us augment data.csv, which is not visible here because it's of its sheer. Okay, I got it. So yeah, so what this does is this creates a very large data set for us to work on and train our model on, which will finally be used in our final model, which I will speak about in a further video. Thank you.
Now that the data has been pre-processed, we can now send it to our models.
Now I'm going to talk about our ML model and final results of our project. So basically what our project aims to do is to give a personalized stress report based on the mobile game that the user has selected. So we have considered two mobile games. One is Clash Royale and one is Geometry Dash. So after the initial pre-processing of the data, we separate the features and target variables. And since every experiment has a control and the actual experiment, the control we have chosen is a linear regression model. So this model we are using to predict the stress values. So here we have plotted our linear regression values and we've got a mean square error of 7.4, and for Geometry Dash, and for Clash Royale we've got it as 8.19. So as we can see here, the linear regression model, it doesn't do a pretty good job at predicting the heart rate values and for both the games. So now coming to our actual experiment, we've used a model called Patch TST. This is a state-of-the-art time series analysis model, which was released in an international conference around last year. And here what we found is one of the specialty of Patch TST is it is able to recognize various trends in a time series analysis, and like it can accurately predict within 96 of the values from the input data. So as we see here, we've predicted it for Geometry Dash. So here, as you can see, the blue line represents the actual values and the orange line represents the trends in the data that we've predicted using our Patch TST model. So as you can see, the Patch TST model correctly identifies the trends in the IoT values and provides a accurate analysis of the report for the given game. We can also see the same thing happen in the Clash Royale dataset. So this, once we've done our initial runs and trainings, we've finally come to a finalized output for the same, which includes uh, so this is the final plot, that is the Clash Royale actual versus predicted plot. So as you can see, the same color conventions, orange for our predicted and blue is the actual time series analysis. And what we found here is we've found our accuracy for our model to be 75% for around 75 to 80% for both our models, which is great given our data set and our training time. So I will show what the results mean so that it's better understood. So here we've plot for this is for the Clash Royale game. So this is a analysis for a person who has played the game before. So here are his BPM values. The blue line indicates his BPM values over time. The orange dotted line indicates the moving average, and the red dot indicates the highest BPM, and the green dot indicates the lowest BPM. We can see how this differs from a person who has played little to none of the game before. So this is his BPM value, more varied. And then we've also plotted for someone who has played it more frequently. And this is all the all combined graph of all. So, and now I will show you for the Geometry Dash dataset. So here is the one for a person who has played it frequently. And then we also have one for a person who has played before. And this is for a person who has played little to none. And then once we combine all the three, we get uh, this graph. So this can be used to interpret your stress levels for the game you've chosen. And this is basically the results of our project. So, thank you.